Okay, we've covered a lot of this already, so I will run through this quick. We are still at measuring search performance, this time the F1 score. And the F1 score basically is a trade-off between the precision and the recall. So our two other search metrics, if you haven't watched the videos yet, I have done one on both. I will check them out first. Precision basically asks how accurate are your picks. So if you select 10 documents and 8 are relevant to you, your precision is 80%. Recall asks how thorough is your search. So if you have 20 relevant documents in total and you found 16 of them, your recall is 16 divided by 20, which is also 80%. And the difference between both of them is basically the numerator. In precision, you have 10 as enumerators, which is the number of retrieved documents. In recall, you have the number of relevant documents in the entire database. And because of that, they basically trade with each other. So when your precision is high, you are very likely to have a lower recall because you're incentivized to minimize the enumerator as well. And in recall, if you optimize for recall, you likely have a lower precision because it's easier to just retrieve more documents to ensure you cover the relevant documents. And the F1 score basically tries to strike a balance between the both, and it tries to avoid the extremes where you have very high scores in one and low scores in the other. And the F1 score is calculated by taking the harmonic mean of the precision and recall. And the formula is here, but in the end, what it really means is if either the precision or the recall is low, the F1 score is low. So if you have an extreme, the end result or the score for the search performance is lower. So this encourages you to have a balanced performance. And when you want to use the F1 score is basically when you need to balance the relevant results versus finding all relevant documents. And this is often useful when you have an imbalanced data set. So you have only few relevant documents among many irrelevant ones, or also the cost of false positives and false negatives is similar. So false positive in search is basically I have returned a document and said it's relevant, even though it's not. False negative is the opposite. Basically, I have not returned a document, so I say it's not relevant, but in truth, it's relevant. And you basically have to ask yourself, how costly are the missed results and how costly are mislabeled results, so basically false positives. So this is basically like the standard classification problem. And the classical examples here are like spam detections, disease diagnosis, and literature search, which don't really fit into like the search case or search example right now. But spam detection is basically you try to minimize. I have that wrong here. You try to minimize you try to minimize the false negatives, which is you try to minimize the false positives, which is you classify something as spam despite it being not, because it can be very harmful that you use legitimate emails. The second thing is like disease diagnosis. So missing a case could be very life-threatening, but false positives can be ruled out with further testing. So you're optimizing more for recall, so you are on the safe side. And literature search can, in many cases, be a good case for F1 scores. It, in the end, depends on who the end users are. So in law, this would probably not be the case, but you often want to have like both relevant results and a comprehensive coverage. And some more search examples are basically like a drug lookup for precision in pharmacies, for recall-oriented systematic literature review where you're going more broad. And F1 oriented is likely more like an e-commerce product search where you want to help customers find the desired products and you want to have a good balance. Like you want highly relevant items without missing the potential matches. And this is, of course, it's an oversimplification in the end, because this will highly depend in e-commerce, for example, on the type of query you receive as well. So if you have a highly specific query, or in like search terms, if you have like a tail query, you're better off optimizing for precision. In the case of more of a head query, so very unspecific in general, so for example shoes, you're better off optimizing for recall and showing a broad set of examples so the user can basically explore the space. Yes, perfect. Here's basically the F1 score. We will be covering more metrics, probably also NDCG, MAP, MRR, ERR, and when to use them. Let me know if you want to have code examples or anything. Let me know in the comments. Otherwise, I will talk to you soon.